Okay, so continuing on, the students brought up a good point on in section 1.4, there was one problem that we had, one concept that we missed, which was intermediate value theorem. So I call this kind of the interstate problem. So we're going to look at this theorem, see what it's talking about, but for us, I call it the interstate problem. And I think if I explain that in that way, it'll make sense. So let's first, you're just going to write the theorem down verbatim, and then I'll translate. So intermediate value theorem, I usually just abbreviate with IVT. If f of x is continuous on the closed interval AB, and f of A does not equal f of B. So what we're saying is that we got a continuous function, but the endpoints are not at the same y value, okay? Then this is where it gets a little crazy. Then there exists, make sure I get this right. And let me just say this. Put this, K is between f of A and, let's just say K is between, K is a y value between f of A and f of B. Then there exists at least one x equals C in AB such that f of C equals K. That's the intermediate value theorem. You're going to see, we'll translate it here, make some sense of it. All right, see, it's easier for me when I draw things out in math to understand what they're asking. All right, so then, like I said, I like to call it the interstate problem. So all this is saying is, let's just say you've got your A and your B, and this is your graph here, and it's continuous like that. Okay, here's my graph. And notice that f of A, the y's, f of A and f of B, are not at the same height. All right? So it's going to seem very simple when I say this, but it is true if you think about it. If that graph is continuous from here to here, then there has to be a point in between these 2 points. That's all it's saying. I'll show you where we use this, because you're like, well, why would I? That's silly. But there's a time and place that I think that common sense is useful. So again, here's what it's saying. If we're continuous from here to here, continuous means there's no what? Breaks, gaps. Then there has to be a point in between these 2 points where you're getting the intermediate value. So what it's saying is K, if K is between f of A and f of B, K is a y value, then there has to be an X that gives that YK, and that point is in between the 2 points. So basically, there has to be a point in between AF of A and BF of B. So just what it's basically summarizing is then there has to be a point between A, F of A, and B, F of B. Why does there have to be a point? Well, because the graph is continuous, and it's we know that you can't just jump from here to there, okay? And so that point that we're talking about is that C comma K point, okay? I like to explain this with the interstate, okay? I like to try to talk about this for us as the interstate problem. So if I just kind of put a map here for us or something. Just kind of put, here's Rutherford County. Here's Riverdale. Here's the interstate. Here's the square. So if we were to drive our car from here to the square, is there any way you can get from here to the square without crossing the interstate? So at some point, I mean, you can't say, well, we could drive all the way down out of Tennessee, you know. I'm talking about I-24. So I-24 runs between us and the square. The only way for us to get from here to the square is at some point, we'll have to do what? Cross the interstate. You can't say, well, if I get on the Greenway, well, even if you get on the Greenway, you gotta go underneath the interstate, you still intersect it. So where this typically works is how I'm gonna work example one. Where it typically works is this, is if I take a function and say, here's my function, and I know, say maybe at 1, I know it's got a positive output, and at 0, it's got a negative output. So if this is the graph from 0 to 1, then I know between 0 and 1, there's an x-intercept. Typically, we use it to say, well, then I know there's an x-intercept. So I'll kind of play out this intermediate value theorem right here on example 1 to show you how it works. But basically, all it's saying is that if you have if you have a continuous function, all right, then there has to be a point in between the 2 points, which we know there's a whole lot of choices. But as long as that y is in between those y's, then there's an x that goes to that. So I think it's easiest if we just work out an example and just see how it works. And so example 1, I think, makes the most sense on what we're trying to do. Okay? So let me erase this stuff. So first question, is f of x continuous? If you look at f of x as x squared minus 4, is it continuous? What do you think, Naomi? Yes? Why would you not worry about it? What would you worry about for it to be not continuous? So for this whole section, we look for discontinuities. When did discontinuities appear? And when there was a hole, because you would have to have a fraction, right, and some factor in the bottom. So since I can see that there's no fraction, there's no factor in the bottom, I'm not worried about it. And this is a polynomial. Polynomials are always continuous. So let's look at example 1, and here's how this problem would relate to intermediate value theorem. So what we're going to do is, I think every marker is about, we're going to have to just start tossing. This way I won't miss now. So here's the problem. We're going to find x equals to c in the 0 to 3 interval for this problem such that f of c equals 0. So what's another name for that? If I'm looking for an x value where the output is 0, what's that called? X-intercept. So I'm about to prove that there's an x-intercept between 0 and 3. And here's how I'm going to do it. So if this is the closed interval from 0 to 3, I'm going to find the 2 endpoints. So if I plug in 0 right now, I get -4. And if I plug in 3, I get 5. So if we just kind of picture that real quick with the graph, 0, -4, and 3, 5. All right, so here's your interstate problem again. I know that these 2 dots have to connect. How do I know that? So again, here's where you gotta give evidence. All right, this is why I gave you those characteristics in pre-calc. F of x is a polynomial. Polynomials are everywhere continuous. That is the evidence you give. So you refer back to the function. I know that since this is a polynomial, and I know polynomials are everywhere continuous, I have continuity between here. So in mathematics, you have to be like a lawyer, you gotta give evidence, okay? So I know that it's continuous, and I know a parabola is not gonna have, it only has one peak or valley, and I already kind of have a good idea of this. I know the graph is doing this. So therefore, now what I'm basically saying is that there has to be an x-intercept, at least one between 0 and 3. That's what we're going to solve for. Okay? So basically, the intermediate value theorem, I'm hoping it's like a common sense theorem for us. It's just saying, look, the only way you get here to here is you have to cross the x-axis at least once. All right, and that's what we're going to look for. So what we're going to look for is we're looking for this point. What coordinate is known right there? What is known? One of the coordinates is known. Which one? So what axis is this? And what do you know about one of the coordinates always at any point on the x-axis? The y is 0. That's what this is saying. Find the c, so find the x value where the y is 0. That's what this is saying. That's why I put that. So all you're going to do is take your function, f of x, set it equal to 0, and you're going to solve for x. So now it becomes an algebra problem, not a calculus problem. So the problem is, can you solve and find an x that's in between 0 and 3? Right? That's what you're looking for. So now you got to use algebra to solve for x, to find what's the x so that the y is 0. Go ahead, there's different ways to do it. So, what choice? What's the best way to solve? You can add the 4. 4 is x squared, then what would you do? Square root. Now typically when you do square root, you should put plus or minus. However, we don't want both of those answers. We only want the one that's between 0 and 3, so you'd only keep the 2. So for this problem, find this x in this interval such that f of that x is 0. And so our answer by the intermediate value theorem, x is 2. Because what happens here, we know that that point exists and it gives us the y that we're asking for, the y is 0. And this y is in between these two y's, okay? Now it doesn't always have to be y is 0. For me, that's the one that makes most sense. So now we're going to look at example 2 and you can see it's a different y, 8. We're going to prove that there's a point with the y value 8 in between the two endpoints there. So we're going to look at the two endpoints. All right, so let me erase this problem and let's look at the next one. Once you guys give me the thumbs up. Can I erase the blue here? You guys got it? Okay. So let's look at the example 2. So again, it says find any x, find c guaranteed by the intermediate value theorem. So what I'm doing is I'm telling you that what y value should be between the two endpoints. So again, here's what I'm going to do. I'm going to, and I picked the quadratic again because they're easier to solve, but I just want to get the point across of what we're doing. So real quick, if I plug in the endpoints, if I plug in a 0, I get 5. So there's the endpoint 0, 5. And if I plug in a 4, 16 and 8 is 24. I got 29, something way up here at 29. Okay? And I know more than likely it connects like this. Okay? Now, what we're saying is that there has to be a point that has a y value 8. So 8 would be here. So let's just say whatever this graph is doing, I'm looking for that point. So what x will give me a y value 8 on this graph? Why is it 8? Well, I just picked a y value between these two y's. Okay? So basically all you're doing is you're going to take your function and you're going to set it equal to that y to find the x value that gives you a y value of 8. So I've got to see what does x need to be so that my y is equal to 8. That's what this is asking. And is that guaranteed by the intermediate value theorem? What is the evidence that we know that that is guaranteed? Is f of x continuous? Because it is a polynomial, it is continuous from here to here, and is 8 between the two endpoints, 5 and 29? Yes, so there has to be an x that gives that y value 8. So then all now becomes is an algebra problem. You take your function and you set it equal to the y value that you're looking for, and you only want solutions for x between 0 and 4. Why 0 and 4? Because that's our interval, so we're looking for something in between there. So you may get more than one answer, but you only want the answer between 0 and 4. All right, go ahead and use whatever good math you can do. Hopefully I made this problem up properly. And my picture's a little off. Okay. What's the best way to solve a quadratic? What's the fastest way to solve a quadratic? Factoring. Factoring, that's exactly right. So I would take the 8 and move it over and try to factor. It should factor very shortly, very quickly. Notice you'll get 2 solutions, but one you have to discard. Okay? And that's using the intermediate value theorem. Okay. All right, so we'll go ahead and have a look here what we did. So the first thing I'm going to do is move the 8 over, right? So if I bring the 8 over, we now have x squared plus 2x minus 3 equals to 0. And I hopefully can factor that. 2 numbers that multiply to give negative 3 add to give 2. What are the only 2 numbers that multiply to give 3? 3 and 1. Now I need to place them in there so that when they add, I get positive 2. So it's got to be x and x. And now when you get your answers, you get negative 3 and 1. Now those are the answers there, but only one of those I keep, right? Because I'm looking for an x value in that interval. Okay, and so my solution that I keep is 1. Guess what's going to happen if you put both? It's going to be wrong. Okay, you can't give both. You only give the 1. So 1 is in here. So obviously my picture's a little wrong, but 1 is in here, and that we're showing that we have the 0.18. So x is 1. Okay, that's it. So another way for intermediate value theorem is just think a point in between the 2 points. Now, it could be more than one. You could have graphs that do this, right? You could have a graph that does this, and then you'd have 3 points. So that's why it says at least 1 point. Okay? And that would be a tough one to solve, but you could have that. Okay? All right, that's the one problem. So that was in 1.4 that I had left off, so that's my apologies. So in 1.4, what problem was that? Around number what? 10. Around number 10. If it asks you about intermediate value theorem, that's the steps you take. So we're going to stop this video here, and this video is just on intermediate value theorem. Again, I like to think of it as the interstate problem. We can't get from Riverdale to the square without crossing the interstate. So there is that, we have to hit that point. And that's basically what we've been saying on these. So we'll stop this and we'll move on to 1.5.